Hey guys, just doing a short video on hardness testing. We have 6 blades here that just came out of temper, and basically it's just this unit here. We have a little 3D printed stand that goes on top of the box. Wind it back. This uses a conical diamond to pierce the surface of the metal, and it measures basically how deep the diamond goes, which gives you a Rockwell hardness measurement. So the reason why the blades are hard is because we heat them up to 1920 Fahrenheit, and it kind of melts all of the goodness inside the mixture. And then when we quench it, it solidifies all of that in a certain state, which ensures that it's very hard, but in that state it's also very brittle. So then we need to bring the temperature up, which sort of softens it, but it leaves it in that nice hard state. And the amount of time and the temperature that you temper it at brings it to the hardness that we're looking for. And I'm sure Angelo could give you better information on that. But yeah.
So here we have our Ames Hardness Tester that we use in the shop for checking all of our blades. We do 100% check to ensure that not only is not only are we controlling our temperatures, but also within one batch, you might get a range if, say, the oven's not firing properly. You might get a range of temper between them. So we check all of them and to ensure that all spots in the oven are going to be giving us the right temper. One thing that we'll talk about is how we calibrate this. So this is a smaller sort of hardness tester. It requires a modicum of attention because you have to line things up properly. So when you're using it, you have to practice a little bit in order to ensure that you're going to be doing it right. We've taken this hardness tester, we've checked it our standard, and we've also calibrated it against 2 other hardness testers, standard hardness testers. I have one myself. We checked one in another shop as well, and that way we can ensure that what we're reading here is going to be exact, or we know whether it's a point or 2 up or down, and we can kind of work within that. So that way we're always ensuring that we're going to be hitting the RC that we want and the right range for this material. So we're constantly checking this to ensure that it's always going to be reading the right amount, because it's pretty easy if you're banging these things around to mess them up, or if you're using this incorrectly, you have to only check it on one side of the scale. You can't check it on this side. If you do, you're going to affect it. You can't check too close to each other. There's a few other factors to consider there. So yeah, that's a little go through of how we hardness check each knife, and so that you guys, the customers, can get something that works really well. We're not just relying on what it reads out on the digital control. We want to ensure physically that every blade is at the hardness we want. So every time we test it, you're getting this little indentation, which the diamond is essentially pressing into the material. We put it in this area here, or a bit lower, close to the edge where it's going to be, and an area where it's going to be removed via machining. There's very little heat being put into this, so we're not really concerned about drawing away any carbon via getting too hot, or changing the temper when we machine it later. So that way the hardness we get here will be as close as possible as we can get to the stock after stock removal. So it's pretty accurate, and it works for us. And that's how you get an optimal performing knife.
So we want to turn down this screw here until the dial goes to set. When the dial's at set, we wind the scale all the way to the top, line up your eyes on this lens here, and then in one swift motion, crank it to 150 and then back to set. And if you don't move your eyes, you can get an accurate measurement, and this looks like it's right around 60 Rockwell C, which is exactly what we want. 60 Rockwell is the perfect spot on the Rockwell scale for us. For the steel we use, RWL34, it's right in the sweet spot between edge retention and toughness. So you won't get a dull edge very quickly, but it's also not going to chip out on you. So now I'll just repeat that process on every single one of these blades to ensure that our tempering worked properly. And it's important to be mindful where you put the diamond when you're piercing the surface, because it will leave like an indent. So we always have to make sure that we're hardness testing in a spot that's going to get milled off later, or else it'll leave a big dent in the blade. So like a ±1 is acceptable. This isn't the most accurate tester as well, but it works fine for what we're doing. We can get it accurate enough. So thanks for watching our hardness testing video. I'm sure we'll show some more of it another time or go into more detail if people are interested.